Okay, inscribed angles. So let's look at the next section today. You will find measures of inscribed angles and the measures of the angle of inscribed polygons. Our main focus is going to be this inscribed angles thing. So what do we got here? Well, what we got is an inscribed angle. Okay, so let's take a circle with a center. Circles have centers. And let's take a point R. And let's make a chord to say S. And let's make another chord to say Q, because why not? So we've got this two chords. And inscribed, this right here, the angle that's formed, angle R, let's say, is called an inscribed angle. What is an inscribed angle? It is an angle whose vertex is on the circle, and the endpoints, the chords are also, and it makes two chords, or the sides are two chords of the circle. Okay, there's also an intercepted arc, because with every angle it makes an arc. So like here you can see QS is an arc. An arc has endpoints that are on the sides, that are part of the sides of the inscribed angle, and thus they're on the circle. Okay, so in this case QS is the inscribed arc. I'm sorry, the intercepted arc. So we had an inscribed angle of R and an intercepted arc of QS. So let's look at an example. Actually, we've got three ways we can have an angle be inscribed. One way is the center P is on a side of the inscribed angle. So there you notice that that chord is a diameter. Another way is that the center is inside the inscribed angle. And the third way is that the center is on the outside of the inscribed angle. Each one of those has a special way of looking at that. But here's the thing. And you're going to see this, you couldn't see that a second ago, but an inscribed angle, there's an inscribed angle theorem that says if an angle is inscribed, it is half of the measure of the arc, the intercepted arc, or that the arc is twice the measure of the angle. So, for example, and I gave you one that covers both. Okay, so here's an example. Now, notice if I wanted to find angle P, or if I want to find arc PO. Okay, notice angle P is inside, is the inscribed angle. And here's the thing. This is what I would do. As I go in, I divide. As I go out, I will multiply. So I'm going to divide by 2 here, or multiply by 1/2. Keep in mind, multiplying by 1/2 is dividing by 2. And that gives me 35. So the measurement of angle P is 35 degrees. Since I'm going to go out for the arc, I need to multiply by 2. So 2 times 56 would be 112. So again, in, divide, out, times. So next thing, two inscribed angles of a circle intercept the same arc, congruent arcs, then the angles are congruent. So in other words, if you have two different inscribed angles and they intercept at the, or make the same intercepted arc, then they're going to be incongruent. Okay? So here's an example. Duh. Alright, I got angle T and I got angle U. T is 3x minus 5. U is, I can't even read that right now, 2x plus 15. So, what do I want? I want, say, the intercepted arc of SB. Or, I mean, I don't want that, but I'm saying I know because they both have those endpoints right there in this arc, and that means those two are equal. They're equal. So I can say 3x minus 5 is equal to 2x plus 15. Move the 2x over to the left. Numbers to the right, and you get x equals 20. So then you can put the 20 in place of the x and find angle T if you like. So 20 times 3 minus 5 would have been 55. And thus, you could also find arc SV because you know that if you go out, you multiply by 2. So 55 times 2 gives me 110. Make sure you understand how you can say somehow move around or change up these rules. Okie dokie. Okie dokie, sir. Alright, now let's look at Theorem 10.8. Inscribed angle of triangles intercepting the diameter of a semicircle if and only if the angle is a right angle. Oh, this is important. Notice that if it goes through, if the inscribed angle of a triangle intercepts intercepts a diameter, if and only if the angle, then it's a right angle. Okay? So, notice how that they're saying there that because FJH, or this right here, is going to be 180 degrees, then because, and this goes through that diameter, then G is 90 degrees. Wow. What? 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 Wow. 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 Alright, so what does that mean? Okay, here's an example. Now, we're going to find angle F. Okay, but notice, we got a diameter. The triangle is with the diameter. So that means this right here is 180 degrees. Angle, our arc FH is 180 degrees. I don't know why I erased that zero. Okay, so because that arc FH is 180 degrees, now I know that G, angle G, which kind of is that angle that was created, or the inscribed angle of that intercepted arc, then that angle G is 90 degrees, because again, half of 180 is 90. Okay, so now, and also keep in mind, you now know that a right triangle, like all angles of a triangle, add up to 180. So if you're taking up 90 degrees for one angle, then that means the other two angles have to add up to 90 degrees themselves. So that means angle F and angle H add up to 90, and I can say 4x plus 2 plus 9x minus 3 equals 90 degrees. Which means I can combine my like terms, say 13x minus 1 equals 90, add 1 to both sides, get 13x equals 91, divide by 13 to get x equals 7. Then I can put 7 in place of the x and say 4 times 7 is 28, plus 2 is 30, and there you go. Yes, that might be a few steps. Don't be lazy! Anyways, alright, last thing I want to just say here is keep in mind this. We have one more. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So what they're saying here is like angle L and angle N would be supplementary, and that means add up to 180 degrees. Angle K and angle M would be also supplementary and add up to 180 degrees. No matter how that works, mainly because you can make you have an intercepted, like say, angle that's going through like that, and I'm drawing that horribly. But that arc is going to create something like that. So these two would be adding up to 180 degrees. So, okay, keep that in mind. These two add up to 180, and these two add up to 180. And that's really all I'm going to do today. We are thankful. I am very thankful for your time. Thank you so much for listening. Take care, and let's give you a bonus word for today. Let's see, for the next quiz, let's say quiz. Bonus word. What am I going to do for a bonus word? Let's just go with something simple. Astros. There you go. Go Astros. Thank you so much for your time. Y'all take care.